Alright, this lesson we're going to be talking about the laws of cosines, and if you remember back to the previous lesson we had case 1, case 2, where we worked with law of sines, and then today we're going to use case 3 and case 4 using law of cosines. So I have those just noted there. Also, if you'll take a minute to pause this and write this theorem down, our law of cosines are defined down here. So I'll give you a few minutes, if you will, pause it and make sure you get all this information down before we get started. Okay, before we move on to some examples, these are also images of the triangles that if they were placed in a coordinate system like this x is to the right, your y value is going to be up or down, then this ordered pair, this is when angle C is acute, and of course these are angle C, side C, so on and so forth, like we've been working with. But this ordered pair can be represented by B, 0. So if you think to your xy coordinate system, and we can find this point performing these calculations. If angle C is obtuse right here, we can see that then this is defined by B0, this ordered pair right here, and this ordered pair up here could be solved for using A cosine of capital C and A sine of angle C as well. So we'll keep those in mind as we move forward and work on some examples. Alright, so our first example is just going to say solve the triangle. And we want to identify all the given information, and notice that this is a side, angle, side. So side given, angle given, side given. So this is one we want to use. Let me remind you, side, angle, side is a case 3. So we want to use laws of cosines, which are, we're given the options below. So these right here. So we can either solve for c squared, b squared, or a squared. In this particular case, which one do you think we need to solve for? Yeah, right. The lowercase b is the only side that's missing. So let's pull our formula from law of cosines from the previous page, if you will. Let's pull the b squared equals a squared plus c squared minus 2a times c cosine of angle b. Okay, now we chose this one because we can clearly see that side B is one of the sides that are missing. So we want to solve this for B. How do we take care of that? We'll square root, right? Okay, so first of all, I could take, let's plug in, we'll have B squared. Actually, let's just go ahead and take the square root of the entire thing. So a squared plus c squared minus 2ac cosine of b. I want to just be able to show this. Square root there. I'm also going to square root this side. Whatever you do to one side, you're going to do to the other. Okay? Now, what's the square root of b squared? It's just going to be b, and that's what we're looking for. Now let's plug in what's the square root of a square here. You're just going to be left with the a, which is, right, so if I plug in this a is 3, c is, what's c? 5, minus 2, let's plug in a, let's plug in c, cosine, and we'll plug in angle b, which is 36 degrees. Let's go back and plug in our a was 3, and our c is 5. So now that we're going to plug into those values, we'll have this. So just continuing to simplify, let's leave that square root there. What's 3 squared? 9. What's 5 squared? 25. And then that's just going to be 2 times 3 times 5. So that's what 15 times 2 is 30 cosine of 36 degrees. Alright, let's go ahead and put this in your calculator and simplify under here first. Okay, there's more than one way to do this, but if you want, you can go ahead and put your square root in your calculator. Then it's going to open a parenthesis. Go ahead and put 9 plus 25 minus 30 cosine 36. Close your parenthesis and then hit enter. You should get that b is approximately 3.8 11 119213069. So let's just round that to approximately 3.12, 2 decimal places. Okay, next so we found side B. What's our next task? We need to be able to find angle A and angle C. Now, usually the angles are the easy parts because in most of the cases they've given us 2 angles and all we would have to do is know that all 3 angles add to 180 degrees. But this time's not quite so simple because I don't know either one of these. So one of the things I can do is let's just attempt to solve for A first. Which one of these formulas includes capital angle A, which is a capital A? Right, this bottom one. So this is why we're going to choose this one because we want to find out capital A, which is angle A. So I'm going to pull this one to our next page and let me do this in red. So I'm going to have A squared is equal to B squared plus C squared minus 2bc cosine of A. Okay, our goal is to get the cosine of A by itself. Okay, so we're just going to be doing some rearranging here. I want to get this term by itself, and I see that it's negative. So the first thing I'm going to do is I'm going to add this to both sides. So that means 2b times c cosine of A. Alright, I'm moving this over here, so now it's positive. And I want to move everything else to the other side. Well, the b squared is already over there, so I'm going to leave it alone. And so is the c squared. It was already on the right of the equal sign. But what about a squared? What do we need to do? Subtract a squared from both sides, so we're going to move it to the other side. So basically, all we did in that step was move this term to the left and this term to the right of the equal sign. So our goal is to get this by itself because we want to end up finding out a. So what are we going to do? Divide both sides by 2bc. Whatever you do to one side, you'll do to the other. So then we're left with cosine of A is equal to this entire right side. Now, how do we get just angle A? What property we use? Our cosine inverse property, right? So what we could do, and we can plug in some of these values here. Let's go ahead and plug in these values first before we do our cosine inverse. Let's see if we can simplify cosine of A before we do our next step. So what is B? B squared is, that's that 3.12 that we found. C squared is, what's that over there? 5 squared. Minus A squared, which our A was a 3 squared. A 3 squared, and then we have 2 times B times C, which was 5. Let's do some calculations. So if you will put this in your calculator, square this, and then you're going to have plus 25 minus 9 over this. So divide that, and let's simplify this to where we'll get cosine of A is approximately, when I plug all that in my calculator and simplify, I'm going to get 0.8248. Okay, that's the calculation I got. Well, that's cosine A. I don't want cosine A, I want angle A. And like we were saying before, we knew we were going to end up using our cosine inverse. Remember, if I multiply this by cosine inverse, then I can multiply this side by cosine inverse, and that will give us just A is equal to, plug cosine inverse in your calculator of this value, and you should get approximately, it looks like it's 34.4 degrees. Okay, so the only thing I have left now is angle C. I have 2 options. I can either do this entire process with the cosine formula that involves the capital C, which represents angle C, or what's the other option? Now I know that all these angles add to 180 degrees. I could just subtract that out. So I could say, let's see, so A is 34.4 degrees plus B is 36 degrees plus angle C, I don't know, should all add up to 180 degrees. And if I calculate that, I'll get that C is approximately 109.6 degrees. So you have an option there. Of course, like we said, using this one implies that we got this one correct. So if you're pretty confident in this calculation, this of course is going to be the easier step. And if not, then I would recommend you do this using the formula that involves cosine of capital C, angle C.